10. Right here. Ah, my pen's dying on me. Here's another pen. This is your D's. That's your D block. How many electrons can an S orbital hold? Where do you think those are? This whole section here across the bottom. These are S. Oh, because these two rows actually belong right here. That's what those symbols mean. Yeah, they belong like inserted right in there. Yeah? Okay. So the first thing we're going to do is we're going to write the electron configuration. Electron configuration. We're going to start with hydrogen. And we're starting with hydrogen because it's the first element. Yep. Now remember the numbers we wrote down on the left-hand side here? Remember these numbers? These stand for energy levels. Which scientist said that electrons had orbitals and that it's a different energy level? Who was it? Niels Bohr. Good job. Okay? Bohr said different energy levels. Who said that the orbitals within the energy levels were different shapes? Yeah. Heisenberg and Schrodinger. Good. That's okay. We'll learn it. Heisenberg and Schrodinger. Okay. So, these energy levels are where these orbitals live. It's kind of like what block they live on. These are the streets and these are the houses. So like these energy levels are like what blocks or what streets that the orbitals live in. Okay? So energy level 1 is where we're going to start. So the electron configuration for hydrogen is 1 s block. And how many electrons are in that orbital? 1. Think about it. Hydrogen has how many protons? 1. So it has to have how many electrons? 1. How many electrons does it have? 1. That's how you check your answer. Alright? So in an electron configuration, the big number is energy level. The letter tells you the orbital. And the superscript tells you how many electrons are in that orbital. This is the address for that electron. It lives in energy level 1, the s orbital, and it lives by itself. Oh yeah, we're going to do the whole thing. That's for hydrogen. Okay, remember how I said helium can kind of be a pain in the buttock? Right. Your periodic table is designed the way it is because of the way electrons fill in their orbital. So, in reality, helium belongs right here. It's not over there because it behaves like these guys. Remember Mendeleev built the periodic table based on how they behave? So it behaves like here, but electron fills like here. Some periodic tables will have helium in both places. Some will have it up in a corner by itself on one side or the other, because it kind of belongs in both places. Okay? So I want you to, in pencil or somehow, put it over here also. When we're talking electron configuration, we want it to be here. Just the block with the HE. here's why. We're going to do the electron configuration for helium next. What energy level are all of the electrons in? 1. What orbital are they in? S. And how many electrons live in that orbital? 2. You will never have an S orbital that has more than 2. Because it behaves like these guys. So that's why it's over there. But it fills like these guys, which is why it's over here. Yep. So the small, these ever be negative? No, they're always positive. Because there's 1, 2 blocks. Helium has how many protons? What's its atomic number? 2. So it has how many protons? 2. So it has to have how many electrons? 2. So if I count the superscript, 2. Ready to get tricky? I think it's time to get tricky. Let's skip to beryllium. We're going to skip to beryllium. Now, remember, I need the address of every electron in the atom, every single one. And how many electrons are in beryllium? 4. 1, 2, 3, 4. So we always start at the beginning. Alright, so we always start at the beginning. So the first electrons are in what energy level? The first ones start in 1. We always start in 1. It's like reading a book. You always start at the top left and go all the way across before you go down to the next line. It's going to be 1, S,